This video is on estimating quotients with compatible numbers. Before I begin with the process, I want to take a moment and talk about the terms that we're using in our title. So estimating, let us know that we are going to be rounding our numbers. Quotients, representing the answer to a division problem. So we are rounding in order to find the answer to our division problem. And compatible numbers. Compatible numbers are numbers that work well together. And in using them with finding quotients or the answers to division problems, that's going to mean that we are going to be able to divide them without getting a remainder. So being as we just kind of defined three terms, there really is somewhat of a three-step process to this. So since we are estimating, that should be the first thing that we do, is we do want to do the rounding piece first. And we talked about reasonable estimates. 22 would reasonably round to 20, and there's no other reasonable estimate for that. We would not round it to 30, as 20 is the closest number that ends with a 0. Now 396, we could reasonably round that to 400. There is no other reasonable estimate for 396. So we've taken the estimating piece. So now we want to talk about quotients, the compatible numbers. Now with division, if both numbers end in a 0, only with division, then we can eliminate a 0 off of each. And it has to be the equal amount of zeros on each side. So if I take 1 0 off here, I can only take 1 off this side. Now I just need to divide the remaining numbers, but I need to make sure they're compatible. Meaning if I divide 40 by 2, I should not get a remainder, and I do not. 40 divided by 2, or if we're finding half of 40, is 20. So a reasonable estimate for 396 divided by 22 would be 20. And estimates allow us to determine reasonableness for our exact answers. So if I now were going to do 396 divided by 22, I know that my answer should be near 20. If it's not, then it allows me to know I need to go back and check my work. So another example, 375 divided by 78, and 78 can only reasonably round to 80. We're looking for the closest number that ends with a 0. So now I need to round my 375. Now this one actually has a couple options. If I round to the nearest 100, I'm going to round to 400. It's the closest 100 to this. Or my 78 is still going to round just to 80, but I could also reasonably round 375 to 380 if I am rounding to the nearest 10. So we are actually going to deal with two answers to this question, and that happens sometimes with estimating because it depends on how you choose to round. Did you choose to round to the nearest 100 or to the nearest 10? So now let's go solve both of them. As I mentioned, I can cancel a 0 off of each, and we're left with 40 divided by 8. 40 divided by 8 is 5. Now if we come to the other one, I can eliminate a 0 off from each, and I've got 38 divided by 8, but those are not compatible. If I divide 38 by 8, I will get a remainder. So this is where the compatible piece comes in, and we haven't had to do this yet because so far we've dealt with compatible numbers. So we want to think, what is the closest number to 38 that is compatible with 8? So we're going to think of the multiples of 8. 8, 16, 24, 32, 40, so on. Well, in that list, 40 is going to be the closest number to 38 that is compatible with 8. So I'm going to adjust my 38 to 40, which is fine to do because we are estimating. 40 divided by 8 is 5. So I've actually seen that 5 is going to be my only reasonable estimate for this problem. One last example. So we're going to estimate our quotient. 28 can only reasonably round to 30. And 232, I could reasonably round that to 200 if I'm rounding to the nearest 100. Or I could reasonably round that to 230 if I'm rounding to the nearest 10. So again, I've got two problems to solve. Now you don't have to do both. You just choose which way that you want to round, whether to the nearest or the nearest hundred. I'm just showing both so that we can see that when you are estimating, there are sometimes more than one correct answer. And as long as you can provide evidence for that answer and it is a reasonable estimate, then there could be more than one correct answer. So in dividing this, I can take a 0 off each. 20 and 3 are not compatible. But if I think about what is the closest number to 20 that is compatible with 3, thinking of my multiples of 3, 6, 9, and so on, 21 would be the closest. 21 divided by 3 is 7. So 7 is a reasonable estimate. Now over here, if I eliminate my zeros, 23 divided by 3, not compatible. 23 is not a multiple of 3. But this time, the closest number is 24. 24 divided by 3 is 8. So we can see with this one, 7 would be a reasonable estimate. 8 would also be a reasonable estimate. And they're both correct because I do have that evidence to support how I came to the conclusion of those estimates. And my rounding was reasonable. I've told my students that you can come up with incorrect answers, whereas if you were to round 232 to 300 and say 300 divided by 30 is 10, that's not going to be a good estimate because you've now adjusted the original numbers so far away from the original value that your estimate is no longer reasonable. So that's why we want to try to stay as close to the original numbers as possible.